Yeah, here we go. This is batch 11, and now we are going to see the communication, like the protocol transfers between I2C to SPI. Here, I2C protocol is basically use two ways of communication, where it uses SDA and SEL, two wires actually, data and a clock, and as well as for an SPI protocol, it requires four wires, MSIO, MOIS, and then clock, SEK, and then a chip select. So these are the things actually. This is our main project where we are going to convert an I2C to SPI protocol. And you might have asked that why we need another two Arduinos over here. We have designed for I2C to SPI protocol, and you might need to know how it is going to work. Is it working or not? So that we need to feed an input. Okay. So we formed an input Arduino. This is an input Arduino. It's an Arduino 1, which is going to convert, which is going to send an I2C data to this Arduino, so that by checking it, like, okay, so you might have tell that okay, fine. Then if the I2C data is received from this Arduino, then you would have checked the data at this point. Okay, so but still we need to know how the SPI data is SPI protocol is SPI is converting the data. Okay, so we went for two Arduinos for the input and output checking, and this is the main Arduino where SPI to I2C to SPI conversion takes place, protocol conversion takes place. Okay, this is an Arduino, this is an I2 2-way communication, as well as this is a 4-way communication. And what we did was by feeding an input to this Arduino will convert UART to I2C 2-way communication, and this two wires are interfaced to this Arduino. So this Arduino will be converting I2C to SPI, and then at the last Arduino, I2C is converted into parallel, and then we are feeding it to LCD screen. This is an LCD display actually, 16:2 LCD display we are using over here, so that whatever the data which we are going to give it as input to this will be transferred to I2C protocol, and it will receive this Arduino, and then it will be converted into SPI, and then it will be sending to this Arduino, and this Arduino will receive the SPI data, and then it will convert the data into parallel port, and then it will feed to this LCD display. So now you can see the output of this program, like is it working or not, and we can have some questions and we will answer for the questions though. Okay, so you may have asked what is this all of these. Okay, so this RXT is a node where we're going to feed an input, and over here this transmitter is the checkpoint of the third Arduino, and then virtual terminal is a checkpoint of the second Arduino. What we are going to do over here is we just receive the data from whatever it is, like if the data is from this UART, we need to display the UART. So for basic information, we need to know whether the input is coming or not. Okay, so we plan to go for an output terminal. Wherever we get an input, we need to print the output, so it will be easier. But in practical implementation, you might have not do. Yeah, you can do it, but still for that you need a computer, so that you can go for an Arduino, and by opening a serial port and that you can see the data whatever transferring through that Arduino. Okay, so in that way we have written a code so that you can able to see it. Okay, so these are all the things. Okay, so this, what is this? This is a digital oscilloscope where you can find the waveform of the I2C data transferring through this window, and over here you can see the SPI data communication, how it takes place. Okay, so now we're going to start. Now the program is running actually. So whatever the data which we're going to give a feed to this RXT is going to transfer to these two windows, and then this is the main output where we're going to see the output. Okay, where we're going to see the output in the display. So now over here I'm going to type H. So you may have, like, okay, oops, everything working good. Over here this is clock and SDA. SDA is going down before the clock, so that data transfer starts, and then this is the address of the slave, and then this is the data takes place, and then this is a stop bit. Okay, that's it. This is the SPI protocol. Okay, you can ask where is the I2C. So sorry, this is an I2C protocol where start bit takes place, address takes place, and then another read write status, and then followed by a data, and then stop bit. This is all the requirements of an I2C data package. So in this, yeah, this is the exact data. This is an 8-bit data. The small things pop up over here. Can you see it clearly? The small thing pop-ups over here, this is actually a data of 8-bit. You might have asked why is it so small. Actually, we are using 9600 baud rate right here. 9600 baud rate means that we are transferring 9600 bits per second, so that in that we are just transferring only 8 bits. So just consider in a fraction of second, 1000 bits, nearly 1000 bits, okay? In fraction of second, nearly 1000 bits. So in each millisecond, a bit will be transmitted. But we are utilizing it by just sending 8 bits, okay? So SPI doesn't have any protocol like start bit, stop bit, followed by address, nothing like that. It just goes through, just like that, it sends a data of 8 bit, okay? That's it. So whenever we pop, like you can see it right now, this is just moving right here. So whenever I type HA, it'll be popping up. Like we might ask, why just it's popping up? It's not popping up, it's just like actually sending a data, but it's so small we cannot visible it actually. It's not visible in this digital oscilloscope though. But in real life, we might have some specialized equipment to view this output. Okay, this is the thing, and over here this is the display part, so that whatever I'm typing here will be displayed over here. By using this all protocol conversion, we converted I2C to SPI. This is a major part in our program, major part in our project actually. This 2 wires is an I2C and these 4 wires are SPI, so that this data, whatever going to come inside as an I2C, is going to convert it into SPI, and then it's going to send it to this Arduino, the last Arduino converts this SPI to an LCD screens data, so that the data is printed at this point, okay? So this is all we can type. So even though we have programmed this LCD display with a specialized program, wherever like normally LCD display, we continue typing over here. If once we reach this endpoint, the data will be starts from here. But in our program, we programmed it to whenever we reach this endpoint, the data in the last line should be moved to the first line, and then we need to continue it again in the starting point of the second line. So this is what we're going to do. We have done, like just like now you can see it like this. Now hi there, what's up? I am okay. So that's it. So you can see there whatever I type here is coming at this point, okay? That's it. Like even though you can visible at this point, like I'm continuously typing, so the data are transmitting continuously, like it's like this kind of spike, okay? But still, even though when we zoom it when we zoom the each pulses, you can able to see the 8-bit of data in the thing, like same information, equivalent data, 8-bit data of HAI space DHE, whatever the data is equivalent to that, it will be transmitted in 8-bit of content, okay? That's it. This is the program we have done, and I will show how I will explain the code of this project. Now we didn't do anything so complex, just like that we have used Arduino, we have utilized Arduino actually. We have learned something about header files, we have learned something about SPI.h, we have learned something about wire.h, we have learned so much of things, but while exploring over here, like I will tell you something important things actually. What did it do in the program was, we just went through the header file, and I will explain what this header file is actually doing. So nothing, we just included a header file in the program, and then we went for and wide setup. So over here we are. This is on wire where I2C protocol is initialized, and then the setup. Over here, a serial pin begin at 9600. This is a baud rate about what we are using for the serial communication for the UART input to the I2C output, okay? So where over here we are beginning wire. This wire means that I2C. Wire is two-wire communication. The I2C is maybe also called as wired communication, as I2C as two-wire communication, okay? And we are setting the clock rate to 4 lakhs actually. So there is 4 kb per second. We are utilizing the I2C in a maximum rate of transfer, so that it will be easier, like faster communication. Okay, so in while loop we didn't do the program is not that much complicated actually. We just this while loop runs whenever we have an UART input, actually serial data. Whenever we have a serial, whenever the serial is available, we need to go to this loop, okay? Whenever the serial is available, the data is read from the serial, and then it's stored to the variable C, and then we start a transmission. Wire.transmission is a header file. Like in the header file, there is a function called wire.begin transmission. So what is does was actually wire.transmission followed by this phi is means as address actually. This phi is in slave address, okay? So when we program for another Arduino, we need to mention that wire.begin at the phi, so that Arduino will identify that I am is a 5th slave. Like I have an address known as phi, so that I am is a slave. I am not a master. I am not going to control anyone. So it will know that, okay? So over here we have started a communication for the 5th address. Whatever the device which have the 5 address, it'll receive the data. So I'm writing wire dot write c. C is a variable which is having the data, whatever I'm given as an input. Okay, so the data is transmitted to the wire, so this data is transferred to the I2C. Then wire dot end transmission, so we are ending the transmission right here, and then we are going for the second Arduino. So second Arduino, nothing we have done, even that is not much complicated, but still it has some simple complex, like some of the complex steps. Actually we need to initialize both the thing. Actually we need to initialize I2C as well as the SPI, so that you can use it, you can convert it in the, you can receive the data from the I2C, and then you can transfer the data by using SPI. That's it. We have initialized both things, like wire.h and then SPI.h. We are initializing the data over here, even though you can initialize at the point wherever you want. I've initialized it before, so that I can, it'll be easier actually for me. So it's up to you, you can use it however you want. Okay, over here, like as I said before, wire.begin.5, it's bracket in 5, so that this Arduino is a slave, it has an address of 5. Okay, that is what it's meaning. Okay, so SPI.begin, I'm beginning the SPI communication over here, CL.begin at 9600 baud rate, and then for the SPI I need to initialize that how much of data, how much of clock speed, and then master bit, and then what is the bit first should be transmitted. Actually in SPI there is 2 modes. Actually master bit can be sent first, and the least significant bit can be sent first. Okay, so that's what over here, like I'm using the SPI mode 0, SPI mode 0. So like even though you can, there are 4 modes, SPI mode 1, mode 2, mode 3, mode 4, whatever mode you want, you can use that. And then for this is my board actually, so I can use clock divide 4, 2, 4, 6, 8. There are 5 clock device, so it's depend upon your device, whatever you are using. So I'm using Arduino to Arduino, so that I'm using clock divide by 8. So basically SPI has chip select, so there is 4-way communication, MISO, MOSI, and then chip select and clock. So I'm using chip select over here. Like actually chip select will be high, whenever we are starting the communication it will be low. Okay, that's what I have initialized at this point. Wire dot this program goes to the interrupt routine. I've set in wire dot clock set equal to 4 kb, but this is useless actually, because in I2C communication only the master will be sending the clock, but master will be sending clock, slave won't be sending clock. It will be just sending the data, whatever the master is requesting the slave to write, or it's sending data to slave, it's up to the master. Slave is not going to transmit a clock. Okay, so as I said before, we are using subroutine over here. It's not subroutine, it's actually an ISR interrupt. Whenever the I2C input comes in, this interrupt will be popped up, so that in this interrupt, whenever the wire dot available is takes placing, like as same as that first main program, like I would do the same thing. I'm reading a data from an I2C and storing it in the variable name data, so that I can print it. So I'm printing the serial print of data at this point. So this will be at this point this will be useful for the checkpoint. And then digital write SS equal to low. Even advanced is why we need to put low. Like as I said before, this digital write SS low it will enable the communication of the board whatever we have connected. So SS is connected to the Arduino, so that Arduino will be popped up, and then the data communication will take place. SPI dot transfer data. We are transferring a data in the SPI, so that it will convert we are receiving from the I2C, and then it's converting to SPI and then transferring it. This was just, it's not that much complicated. This is a small program, and then we are going for the third program. Actually third program is nothing but we are receiving the data from an SPI, and then we are converting the data into a parallel port, and then we are able to display in the LCD display. So for that LCD display, to make it much easier, we have included the library known as crystal.h, and then we have also included the SPI.h, so you can use the both thing at the same time. So in this I count, it's all used in the program below, and then we have initialized this constant int. The constant int, whatever the variable I'm using here, is a pin for that equivalent. So RS is called a reset is a pin 8, and enable is a pin 7, and the D4 is a data 4, and it's pin 5. D5 is a data 5, it's pin 4. D6 is a data 6, and it's pin 3, and then D7 is pin 2, which as a pivot. And then we are initializing the liquid crystal with an LCD. This is a function of the header file. RS, EN, these are all the pins you want to define it as. Okay, so over here, like as I said before, for the LCD display refreshment, we need a variable to store the previous data without losing the data. So we have went for the name.20, so that whatever data I'm receiving, I will be storing it continuously in that. so that I can use it for future uses. Whenever I reach the end, the last line of data will be transferred to the first line. That's what we have did out here. And then setup, we are just beginning an LCD display within 16x2. As I said before, we are using 16x2. So the LCD begin is 16x2, even though there are 16x16 and so much like that. Whatever you want, whatever you are using it, you can initialize like that. But I have used 16x2, so I went to 16,2. Serial begin at 9600 baud rate, a pin mode, MSI voice output. Actually, basically MSI voice an output, but still though we have different over here. SPCR is a special function register where the data will be received and stored in that. We have declared it. And then receive is a boolean function. We have initialized that as a false. And SPI setting, as we did before, as same as that, it should be like that. It should be same as the master device. So we have went for the 1 crore 40 lakhs actually at this point, and MSB first as same as that in mode 0. As I said before, there are 4 different modes of clock divide. We have went for the SPI clock divide by 8. So I've used in the master, so I'm using the same in the slave. And then even though this is all happening by using an interrupt, ISR interrupt of an SPI pops up whenever the SPI data comes in. Whenever the SPI data comes in, the data from the SPI is stored in the register known as SPDR, so that the data is transferred from SPDR to the slave received, and then we are enabling receive to true. So while loop, this was just small program where we went for the LCD refreshment and something like that. It's not that much important. Like if you are so important, if you have so interest in your LCD display monitoring or something like that, then you can do so much of research in that. After that, we are just sending the data, and that's it. This is all our project, and everything has been explained. Thank you.